Bismillah, alhamdulillah, sallallahu alayhi wa sallam, wa alihi wa sahbihi wa ala. Any questions before we continue? Any questions before we continue? Fine. So inshallah what we will do today is after we took the two examples of rabbits with Tower of Hanoi, inshallah we will take more serious examples that are related to what we have done earlier, like in chapter 6 or chapter 7. So for example, let's look at this example. Find the recurrence relation and give initial conditions for the number of bit strings of length n that do not have two consecutive zeros. The number of bit strings of length n that do not have two consecutive zeros. Fine. So what I will do is the following. If this is my bit string, I know for sure that it will start with a 1 or a 0, صح ولا لا?
Yes.
Okay. I know that it will start with a 1 or a 0. طيب. Now, how are we going to solve this type of questions using recursion? Well, what we will do is we will use when we did in chapter 5, nasheed min nasheed. It's exactly the same. That's the main idea behind trying to solve these questions. So let us assume that an is the number of bit strings of length n that does not have two consecutive zeros. Okay, let's assume that, an is the number of bit strings of length n that does not have two consecutive zeros. طيب. So now, if I look at bit strings, I know that, the first bit string could be a 1 or a 0, صح?
Yes.
طيب. If I count the number of bit strings of length n that start with a 1 and do not have two consecutive zeros, and I count the number of bit strings of length n that start with a 0 and do not have two consecutive zeros, what will be the total in that case?
Two.
Again, let me ask again. So if I count the number of bit strings of length n that start with a 1
Yes.
and do not have two consecutive zeros, and I count the number of bit strings of length n that start with a 0 and do not have two consecutive zeros, what will be the total number of bit strings of length n that do not have two consecutive zeros?
Half the numbers.
No, I got this number and I got this number.
Yes.
What will be the total?
All.
The sum, because it is using the sum rule, صح?
Okay.
يعني all bit strings of length n, they either start with a 1 or a 0, صح? طيب. Now, let's look at the bit strings that start with a 1. How many bit strings that start with a 1 that have two consecutive zeros? Hint, use recursion, or the recursive definition. How many bit strings of length n start with a 1 that do not have two consecutive zeros?
Every other one.
Hmm?
Every other bit string.
Remember, what did I define an?
Number of bit string.
Of length n that do not have two consecutive zeros, huh?
Yes.
طيب. If I start with a 1, look at those n minus 1 bits. do I have any restriction on them?
Not having consecutive zeros.
يعني for example the digit next to the 1
Yes.
right after 1, do I have any restriction on it? ولا it should be a general it should be general صح؟ طيب, so if I want to count how many bit strings of length n that do not contain two consecutive zeros and start with a 1, what will that be?
N plus
Wouldn't that be an minus 1? Because you said here, I don't have any restrictions, huh? It applies to any bit string of length n minus 1. If you find the number of bit strings of length n minus 1 that do not have two consecutive zeros, then you have found the bit strings of length n that do not have two consecutive zeros and start with a 1, huh? So basically the number here is an minus 1. Right. Now let's look at the second case. If I start with a 0, do I have any restriction on,
yes.
what is the restriction?
Cannot be zero.
The next bit, صح?
Yes.
أيوة. So this means that I need another pattern when it starts with a 0 so that I can look at a 0 وال1, صح ولا لا?
Okay.
Again, the number will be the sum of the 3, صح؟ لأنه they are all mutually exclusive. Their intersection is 0. This starts with a 1, this starts with a 0, 0, this starts with a 0, 1. All of them are different, صح ولا لا? طيب, how many bit strings of length n do not have two consecutive zeros and start with 0, 0? 0. We're not going to take anything from here. طيب, مين يقول لي how many do I have here?
Minus 1.
أيوة, an minus 2. an minus 2. طيب, do I have the total now? So what is an?
1.
an minus 1 plus an minus 2. Okay? an minus 1 plus an minus 2. طيب. an minus 1 plus an minus 2. What is a1? Because we need to find the initial conditions, صح? How many initial conditions first do we have? We have 2, صح? We need 2. a1 و a2. طيب, a1. How many bit strings of length 1 do not have two consecutive zeros?
1.
2.
Oh, yes, it's 1.
عندك 0 وعندك 1, صح? So a1 is equal to 2. طيب. What about a2?
1.
How many bit strings of length 2 do not have two consecutive zeros?
3.
Do not have.
2.
Do not have two consecutive zeros. انت عندك 0 0 وبعدين 0 1 do not وال1 0 do not وال1 1 do not.
Oh, okay. Yes.
So a2 is equal to 3. طيب. So now if I want to calculate a5, what do I need to do? خلاص, I need just to apply the recurrence. صح? So a3 is equal to what? Well, a3 is equal to a2 plus a1 which is equal to 5, صح؟ وال a4 ايش بيساوي؟ a3
plus
plus
A2.
a2 which is equal to
5 plus 2.
5 plus 3, 8.
Okay, I found this on the web for 3 plus H2O, which is equal to.
Nobody asked you. Come on. Oh, man. طيب. A5, does that remind you with anything?
Yes. Chapter 2. Recurrence.
No. Much more recent than chapter 2. Day before yesterday. Fibonacci, this is the Fibonacci. It's just the first two terms are not there. 1 1 is not there. We're starting from 2 3 5 8. صح? Okay? واضح يا شباب؟ طيب. Now, let's see whether we got it. Let's now take the complement. What do I mean by the complement? Find the recurrence relation for the number of bit strings of length n that contain a pair of consecutive zeros. That contain two consecutive zeros. Okay? طيب. So again, let's do the same thing. So if I have this is 1 and this is 0. طيب. Now, how many do I have from here?
0. We have 1.
Remember, don't forget, let an be the number of bit strings of length n that contain two consecutive zeros. Okay? Length n contain two consecutive zeros. طيب. If I start with a 1, do I have any restriction on the n minus 1 here?
No.
So how many bit strings of length n do have two consecutive zeros and start with a 1? n minus 1. صح? Because this is n minus 1. طيب. n minus 1 bits. طيب. Now 0. Do I have any restriction here?
1. Can it be 1? No.
No, it's the same. It's the same as the previous example. Now you tell me why.
إذا كانت 2 zeros حتكون AN.
How many bit strings of length n contain two consecutive zeros and start with 0, 0?
AN minus 2. And start with 0, 0.
That start with 0, 0. All of them. ايش هم all of them? All of them. ايش هم all of them?
N.
Chapter 6. ايش هم all of them? لا. 2 to the 7. ليش 7? And I have n. This will be 2 to the power what?
N.
لا. 2 to the power n minus 2.
2 to the power n minus 2. Oh, okay. It's
2 to the power n minus 2. All of them. All of them are included. Because it starts actually with 0, 0. صح? طيب. What about here?
n minus 2.
A n minus 2.
Okay.
Right? This is because here I have a 1. So how many do I have of length n that start with 0, 1 and have two consecutive zeros? Well, it's exactly the same as the number of bit strings of length n minus 2 that have two consecutive zeros. Okay? So therefore, what is the value of an? An minus 1 plus an minus 2 plus 2 to the power n minus 2. Okay? So now, how many initial conditions do I need? 2. ليش 3? 2. صح? So A1 is equal to what? How many bit strings of length 1 have two consecutive zeros? 0. طيب. Will A1 will A2 how many bit strings of length 2 have two consecutive zeros? 1. طيب. So now let's do A3. So A3 is equal to A2 plus A1 plus 2 to the power 1. صح؟ كم بيساوي هذا؟ 3. طيب والA4 اللي هي A3 اللي هي 3 plus A2 اللي هي 1 plus 2 to the power 2. 4. 2 to the power 4 minus 2 is 2. This is equal to 8. طيب والA5 8 plus 3 plus 2 cube صح؟ This is 19 and you can continue to find A7. And you can continue to find A7. واضح يا شباب؟ طيب. Okay. Let's look at this. I'll give you 3 minutes to think about it, and then we will do it together, okay? So a computer system considers a string of decimal digits a valid code word if it contains an even number of 0 digits. For example, 123.040.7869 is valid because it has 2 zeros. If it has طيب 0 zeros, if it has no zeros, valid ولا مش valid? Valid, صح? Whereas 12098704568 is not valid. Why? Because it has 3 zeros. Okay, an odd number of zeros. Because it has an odd number of zeros. Can I start with a 0?
Yes.
The answer is yes. Okay? We treat the code word as a string. طيب, let AN be the number of valid n-digit code words. Find the recurrence relation for it. يلا يا شباب. Try to, let me give you 3 minutes and then we will solve it together. رحمكم الله. Okay. يلا يا شباب. Any ideas? First of all, what are we going to do?
Let
How many are we going to consider?
2
2.
start with 0 or
أنا عندي 10. It should start with a 0 or a 1 هيك لغاية إيش؟ لغاية ال 9 صح؟
Is it the same for all the digits?
Hmm?
Is it the same for all the digits?
Well,
We
let's see now.
we have even 0.
Let's see now. So the number of valid code words of length n that start with 1 is how much?
1 a minus
an minus 1 صح? an minus 1. If I have an even number of zeros here, I have an even number of zeros here صح?
Yes.
So this is, oops. So this is an minus 1. This is an minus 1 صح? All of them from 1 to 9 are an minus 1.
Yes.
طيب. What about the top one?
Doesn't there's 0. So you have
Well, if you add one more zero, you will have an minus 2 صح؟
yes.
طيب وبعدين
Uh,
you need to count 0 1 0 2 0 3.
which is will have 9 again. They will have 0 0 even 10.
have 0, 0, 0, 0, 1.
So 9
طيب
multiplied by n minus 1 plus a plus 10 multiplied by a n minus 2.
it will not work.
Wow.
You know why? You are only considering 0 0 and the rest are even صح? And then you say 0 and then you start with a 1. طيب after the 1 the number there should be what?
0.
Should be odd.
That should be
طيب ما احنا we are already odd here. Can't you estimate the number of odd, the number of even from the number of odd here? Because here, if basically the number of odd, صح? We need the number of odd code words with odd number of zeros of length n minus 1.
yes.
What is that?
10 to the power n.
أيوة 10 to the power n minus this.
Uh,
Okay, so let's write that down. Okay, let's write that down. So the number of the number of code words with even number of zeros of length n starting with a 0 is equal to the total number of code words of length n صح? Of length n minus the number of code words with odd number of zeros. Is that correct? So the number of code words with even number of zeros
The total number of
is equal to no. Well, this is not correct.
Nine.
Let's fix it.
and,
Is equal to the number of is equal to the number of code words with odd number of zeros of length قديش of length n minus 1 صح؟
Yes.
of length n minus 1. Now what is this equal to?
10 to the power n minus 1.
Now this is equal to 10 to the power n minus 1 صح? minus a number of code words of even length صح? minus a number of code words of even length, because I need to do it in terms of an or an minus 1 or an minus 2, number of code words of even length. So this is equal to 10 to the power n minus 1 minus how many number of code words of even length, of even, not even length, of even number of zeros, صح? Of even number of zeros of length n minus 1. So this is 10 to the n minus 1 minus a n minus 1 صح؟ واضح? So what is this equal to? So therefore, now what is an?
10 to the power.
First of all, we have those 9 an minus 1 صح؟ 9 an minus 1 plus أيوة
10 to the power.
10 to the power n minus 1 minus a n minus 1. What is this equal to? 8 a n minus 1 plus 10 to the power plus 10 to the power n minus 1. If you really understand these three examples, inshallah, you should be fine, yani, especially when you try to solve the odd numbered exercises.
Okay. But I got lost with the 0, 1.
Okay. Yeah, so what did you get, where did you get lost?
When it starts with 0, the calculation of the...
So basically, if it starts with a 0, if I count the number of code words of length n minus 1 that have odd number of zeros, then of length n, it will be even number of zeros, صح ولا لا?
Yeah, okay.
طيب, I need to find a number of code words with odd number of zeros of length n minus 1. I want to express this in terms of an أو A, يعني A اللي هي number of valid code words. What is this equal to? Well, this equals to all the code words of length n minus 1 minus n minus 1. فبيضل الأد. وضحت؟ اوكي يا شباب؟ طيب ايش how many initial conditions do I need?
2.
Why 2? 1 an minus 1 أنا عندي.
10 to the power.
So what is a1? How many code words of length 1 have an even number of zeros? 9. 9, صح? A1 is equal to 9, and now you can compute A2, A3, A4.
انسى احنا طلعنا النمبر اوف زيرو.
Yes.
قلنا 10. طب ليه ما طرحناها بالمثال؟ ليه ما قلنا ماينس فتحنا قوس
Here? So, say the question again.
احنا لما طلعنا فوق في المعادله اللي هي 10 ماينس to the power n minus 1.
Yes, the number of code words with odd number of zeros of length n minus 1 is 10 to the n minus 1, which is all code words of length n minus 1, removing from them valid code words of length n minus 1 اللي هم ال n minus 1.
طب هذه اللي طلعت لنا الحين كلها ان فاليد، ليه ما طرحناها بال n؟
لا احنا بنجمعها. احنا we want to add to the 9an those that have odd number of zeros of length n minus 1.
بس احنا نبغى ايفن. تذكر
ما هي لما يكونوا هنا odd في عندك زيرو هنا.
تفزل تفزل
لا هو ناسي الزيرو.
اي فهمت انا.
وضحت الآن؟ طيب. Okay, let's come here now. Find the recurrence relation for Cn the number of ways to parenthesize the product of n plus 1 numbers. x0 times x1 times x2 up to times xn to specify the order of multiplication. Now, first of all, so we are assuming here that Cn is the number of ways to parenthesize the product of n plus 1. So let's look at C2. Let's look at C2. C2, how many numbers do I have for C2? 3, صح? So I have x0 x1 x2. طيب, how can what are the different parenthesizations that I can carry out this multiplication? x0 x1 صح? And then you multiply by x2, right? طيب, what else? x0 and then multiply x1 by x2. By the way, we cannot we cannot switch. It must be in order, and I'll give you the motivation, the real motivation for this problem in just a second. Okay, so are there any other parenthesizations?
Wouldn't the normal way without the precipitation is consider each one having a parenthesis? So wouldn't that?
Yes.
But is this a multiplication? If you have each one, where is the multiplication?
No, I mean we would do parentheses for each one individually. It's not visible, but
No, but you have to carry out the multiplications.
انت بتقول في البدايه يعني
So you are going to either do it this way or that way. There is no other third way.
okay.
صح? There is no other third way. So in this case, C2 is equal to what?
2
C2 is equal to 2, صح? طيب. No, this is C2 لأنه 2 is to have 3 numbers. Cn, you have n plus 1 numbers. طيب. Now, what about C3? Well, let's look at C3. So what do I have? I have x1. Let's do it on the side. I have basically x0, x1, x2, x3. طيب, how many parenthesizations do I have?
x0 x1
Well, first of all, no, let's start.
1 1 1
Yeah. Actually, معلش. I keep changing. So basically we want to carry out x0, x1, x2, x3. طيب. What are the possible parenthesizations? Well, first of all, I can do x0 and then look at x1, x2, x3 ولا لا؟ صح؟ Or I can do x0, x1 as you mentioned in the beginning, x2, x3 ولا لا؟ How many do I have for this one?
هذه زي ما هي.
I have only one, صح؟ طيب. What's the last one?
أول ثلاث
x0, x1, x2,
x3
x3. طيب. How many parenthesizations do I have here? 2, صح? So this one is 2. This one is 1. What about this one?
2
This one is 2. So what's the total?
5
The total is 5. طيب. Now, do you think that this problem is interesting?
Yeah.
yes
How?
Is it somehow similar to Hanoi?
And in my opinion, if you give me this problem, it has no interest whatsoever. You're multiplying scalar numbers. Who cares whether you multiply this first or that first?
I
But let me give you why is this problem really very interesting.
division
استنى شوي. Let's take, instead of scalars, let's talk about matrices. Now, let me ask you the following. If I multiply two matrices, if I have A of size m by n, or B of size n by r, do you know how many scalar multiplications do I carry out? يعني A1, A2 up to AN صح؟ وhere we have B1, B2 up to BM, right? BN, right? And of course, the rest of the matrix. To compute one value, how many scalar multiplications do I have to carry out? N, صح?
Yeah, and
1, 2, 3, 4, N, right?
yeah.
And this is only for one value. طيب. The result is of size what? M by R, صح? So how many scalar multiplications in total? M and R, صح? That's the total number of scalar multiplications. طيب. Now forget about this. Not forget about this. We're going to use it. Now let me give you this example. Let A have dimensions 1000 by 2. B has dimensions 2 by 1000. C has dimensions 1000 by 2. And I want to find A times B times C. Now, definitely in matrices, they are not commutative. Multiplication in matrices is not commutative, صح?
Yes.
I have to do it in this, either multiply AB and then C, or multiply BC and then multiply A by BC, صح?
Yes.
Right. So now, let's look at each one and see how much does it cost. So if I first multiply AB and then I multiply C, let's see how much does this cost. Let's look at first AB. A is 1000 by 2, well B is 2 by 1000. So therefore, AB will cost how much?
1000.
1000
2.
multiplied by 2
1000.
multiplied by 1000, which is
2.
4 million, صح?
Yeah.
Wait, what?
1000.
Two million.
No, 1000 by 1000 by 2.
2 by 1000 by 2 is how much?
2 million.
2 million. Why did I say 4 million?
1000.
صح. 1000 by 2 by 1000
2 million.
is 2 million. Right. It seems I made a mistake in the other section. How can I? The problem is this will all go. Let's do it this way. So 2 million. طيب. What's the result? What's the size of the result AB? 1000 by 1000. Multiply the result 1000 by 1000 by 1000 by 2. How much is this going to cost? Another 2 million, huh? So how many scalar multiplications in total are we going to carry out? 4 million. 4 million. No, we add.
Oh,
We're adding them. 4 million, huh? طيب, let's go to the other one. So let's first multiply B by C. B is 2 by 1000. C is 1000 by 2. How many scalar multiplications? 2 by 1000 by 2 is how much?
4000.
4000?
Yes.
طيب. What's the size of BC?
The BC, 2 by 1000 by 2.
لا 2 by 2.
2 by 2.
Huh?
2 by 2. The result. The resulting
Oh, yeah,
matrix
2 by 2, yes.
is 2 by 2, right?
2 by 2, yes.
طيب. If you multiply 1000 by 2 or 2 by 2, how many scalar multiplications?
1000 by 2.
Another 4000 ولا لا?
Yes.
What's the total?
8000. Oh.
Look at this number. Look at this number. Now, does it seem very interesting to know which parenthesization will give me the minimum number of multiplications? Well, if it happens that you take ICS 353, Design and Analysis of Algorithms, this problem is basically called the matrix chain multiplication problem. Okay? It's an example of dynamic programming, which we are not going to cover here, yani. But
we will have the same result for A, B multiplied by C and A multiplied by C, B, C.
A multiplied by BC. Yeah, of course, you're going to have the same result because matrix multiplication is associative. Otherwise, all what we do is in vain. It is associative. It's not commutative, but it is associative. Okay? طيب. So now the problem became interesting, صح?
Yes.
Now the problem became interesting. طيب. So now, did you notice how do I find a number of ways to do parenthesization? So assume that I have Cn, okay? So basically I have x0, let me go back to blue. So now, assume that I have x0, x1, up to xk, xk plus 1, up to xn. Because I want to find Cn, صح? Because I want to find Cn, so I have n plus 1 numbers. طيب. So now, if I just consider the last multiplication, like for example, where is the last multiplication here? This one, صح? Where is the last multiplication here? It's this one. Where is the last multiplication here? It's this one. So the number of ways to do parenthesization is nothing but the number of ways to do parenthesization on the left of the last multiplication and to the right of the last multiplication. Yani for each parenthesization on the left, I can choose any parenthesization on the right. ولا لا?
Yeah.
So it's basically the multiplication. So for example, to find the number of ways to parenthesize this multiplication, if the last one was this one, اللي هي I do x0 up to xk and I multiply it with xk plus 1 up to xn. This will be what? What is this value? From x0 to xk. How many ways to parenthesize x0 to xk?
K plus 1. No.
احنا what did we say? From x0 to xn is cn plus 1. طيب from x0 to xk?
K plus 1.
ck ولا لا?
CK.
Because I have k plus 1 numbers. So this is
Oh,
ck.
zero.
This is ck. طيب ومن xk plus 1 ل xn, how many numbers do I have? n minus between brackets k plus 1 plus 1, صح?
Yes.
Which is n minus k. I have n minus k numbers. So how many ways to parenthesize n minus k numbers? C
CN minus K plus 1
plus 1 ولا minus 1?
Plus 1.
minus 1.
minus 1 صح؟ C n minus k minus 1. لأنه this one is less by 1 from the number of numbers. تمام؟ طيب. And this is only for 1k صح؟ So if you want to do all the parenthesizations, we need to consider all values of k from k starting from 0 up to n minus 1. So therefore, Cn is nothing but the summation of ck times Cn minus k minus 1, where k goes from 0 up to n minus 1. From k equals 0 up to n minus 1. Just like here. So here k is equal to 0. Here k is equal to 1. Here k is equal to 2. 2 plus 1 plus 2 is equal to what? Is equal to 5, صح? طيب. So that tells us that we need to find the initial conditions. اللي هم مثلا C1. What is C1?
C1. 2.
C1. In C1, how many numbers do I have?
1.
Look,
2.
2. I have 2 numbers. How many parenthesizations do I have to multiply 2 numbers? 1. صح؟ ف C1 is equal to 1. طيب والC0؟ C0 المفروض يكون 0 صح؟ لأنه أنت ما عندك إلا نمبر واحد. C0 you only have one number, right? But what's going to happen if you put C0 equals 0 if I want to find how many ways to parenthesize this? It's gonna be 0 multiplied by this, صح? Although the result should be what? Should be the number of ways to parenthesize this, right? So what does it make sense to initialize C0 to?
1.
C0 is equal to 1 also, okay? So C0 is equal to 1. These, by the way, this Cn, these are called the Catalan numbers, okay? These are called the Catalan numbers, but this is basically the way to find, this is basically the recurrence relation that is used to find how many ways to parenthesize, okay? How many ways to parenthesize. Any question, يا شباب? Okay, I'll go. Okay. طيب, let me first close this.